And moving on to the next part of our discussion on optics, let's have image formation using mirrors. The discussion on image formation using mirrors is divided into two parts. You have mirrors part 1. Mirrors are reflecting surfaces, basically. Thus, mirrors are optical devices that use reflected light, in particular intersecting reflected light, to form images. Regardless of the type of mirror used, we can use the following equations to analyze the optical system and determine the location of the image. You have two equations. You have 1 over S plus 1 over S prime is equal to 1 over F is equal to 2 over R. Even without knowing what these variables are, from the equation, we see that 1 over F is equal to 2 over R. Thus, F is equal to R over 2. Whatever R is, half of this, you have F. And then we have M is equal to negative S prime divided by S is equal to H prime divided by H. S is referred to as the object distance, location of the object location with respect to the mirror. So even though we call it distance, we're actually talking about location, in particular object location with respect to the mirror, how far is the object from the mirror, and what is the location of the mirror, which side of the object rather, which side of the mirror is the object located. Is the object located in front of the mirror or is the object located behind the mirror? To differentiate one location from the other, we have positive, negative sign convention. S is positive if the object is in front of the mirror, which is typically the case. This is particularly true for an optical system comprised of one object, one mirror. If we have one object, one mirror, object distance S is positive. Note that even though S is typically positive, S may be negative if the object is behind the mirror. It's possible to have the object behind the mirror for optical systems that have more than one optical device. For example, a system comprised of 2 mirrors or 3 mirrors and so on, or you might even have a combination of mirrors and lenses. Now, a physical object will always be in front of the mirror. That is to say, S is positive. But if the object is an image produced by another mirror or lens, the object basically is an optical copy of another object. It's possible for it to be behind the mirror. So, if the object, in this case an image, is behind the mirror, S is negative. So again, S is object distance, location of the object with respect to the mirror. The object may be behind the mirror, in front of the mirror rather. The object may be in front of the mirror, S is equal to positive. And if the object is behind the mirror, you set S to negative. On the other hand, S prime is image distance, location of the image with respect to the mirror. How far is the image from the mirror? Where is the image located with respect to the mirror? Is the image in front of the mirror or is the image behind the mirror? Image distance. S prime is positive if the image is in front of the mirror. Mirror is an optical device that reflects light. Thus, we look at the location of the reflected light. Reflected light is in front of the mirror. So we consider the front of the mirror to be the positive side for the location of the image. S prime is positive if the image is in front of the mirror. And since the image is on the same side as the intersecting reflected light, the image formed is a real image. On the other hand, S prime is negative if the image is behind the mirror and the image is a virtual image. F is the focal length of the mirror. Each mirror has its own value for the focal length. Focal length is the location of the focal point with respect to the mirror. Focal point is a reference point of the mirror. Depending on the type of mirror, light will have a tendency to be reflected either towards the focal point or away from the focal point. So again, depending on the type of mirror, the mirror will have a tendency to either reflect the light towards the focal point or away from the focal point. And the location of this focal point, that's the focal length. How far is the focal point from the mirror? Where is the focal point located with respect to the mirror? Is the focal point in front of the mirror or is the focal point behind the mirror? F is positive if the focal point is in front of the mirror. F is negative if the focal point is behind the mirror. Now, F is equal to R over 2, which means we have the same sign convention for R. R is radius of curvature of the mirror. Radius of curvature, which means the mirror has a curvature to take note of. Radius of curvature, location of the center point of the curvature with respect to the mirror. How far is the center point of the curvature from the mirror? Where is the center point located with respect to the mirror? Is the center point located in front of the mirror? Or is the center point located behind the mirror? R is positive if the center point is in front of the mirror and negative if the center point is behind the mirror. And M is referred to as the lateral magnification of the image. It compares the height of the image with the height of the object. If the magnitude of M is greater than 1, the image is bigger than the object. But if the magnitude of M is less than 1, the image is smaller than the object. Aside from comparing the size of the object and the image, aside from telling us whether the image is bigger than the object, the lateral magnification also tells us the orientation of the image with respect to the object. If M is positive, the image is erect or upright compared to the object. The image has the same orientation as the object. On the other hand, If M is negative, the image is inverted or upside down compared to the object. M, lateral magnification of the image. And H is the object height, and H is always positive. It's our reference when it comes to the orientation of the image. We are comparing image height with the height of the object. H prime, therefore, is the image height. Positive if the image is erect or upright compared to the image, and negative if the image is inverted compared to the object. If the image is upside down with respect to the object. M, lateral magnification, comparing image height with the object height. Thus, 1 over S plus 1 over S prime is equal to 1 over F is equal to 2 over R, and M is equal to negative S prime over S is equal to H prime over H. There are two types of mirrors. We have flat mirrors and curved mirrors. First, let's take a look at flat mirrors. For a flat mirror or plane mirror, we have a flat reflecting surface. And for a flat surface, geometry tells us that the radius of curvature for a flat surface is infinite. And since f is equal to r over 2, infinite divided by 2 will give you infinite. The focal length for a flat mirror is infinite. Using our equation for image formation, 1 over S plus 1 over S prime is equal to 1 over F. If we set F to infinite, 1 over infinite is 0. 1 over S plus 1 over S prime is equal to 0, which gives you the following relationship. S prime is equal to negative S. The image is always on the opposite side of the mirror as the object. If the object is in front of the mirror, the image produced will be behind the mirror, which means the image produced is a virtual image. On the other hand, if the object is behind the mirror, then the image is on the opposite side of the mirror. The image will be in front of the mirror. The image produced will be a real image. Say you have a flat mirror. You have the center line passing through the middle of the mirror. The mirror is perpendicular to the center line. Any light ray incident on the surface of the mirror in front of the mirror by convention is on the left side, and behind or inside the mirror is on the right side, again by convention. Any incident light will be reflected by the mirror according to the law of reflection. If the angle of incidence is 0, the angle of reflection will be 0, and the light will be reflected back the way it came. And if the angle of incidence is theta, the angle of reflection will also be theta. We can use this behavior of the mirror. We can use this behavior of the mirror in reflecting the light rays. we can use this to perform ray diagram analysis. Ray diagram analysis, put simply, is drawing the light rays and the reflected light rays, and by looking at the reflected light rays, we are able to determine where the image is located. For example, say you have the center line, you have the mirror perpendicular to the center line, you have the object placed in front of the mirror. Consider the object as a light source. Each point in the object is a light source. Each point on the object will be emitting light. Say we look at the top point of the object. That point is emitting light in all directions. We look at two light rays. One light ray is incident on the plane mirror or flat mirror. Angle of incidence is 0. The light will be reflected back the way it came. And another light ray is incident on the mirror, on the midpoint of the mirror, for example. Angle of incidence theta, angle of reflection will also be theta, and the light will be reflected in this direction. We have two light rays that are reflected. You have one reflected light ray and another reflected light ray. These two reflected light do not intersect, meaning there's no image formed in front of the mirror. But if we trace back the light rays, we see that the traced back line will intersect at this point, which means there is an image formed at this point. Doing the same thing for other points on the object, we are able to form the whole image. Thus, we have an image located here, an optical copy of the object. And we see that the object is in front of the mirror, the image will be on the other side of the mirror. In this case, the image is inside or behind the mirror. You have a virtual image. Ray diagram for determining the location of the image. And that's it for now. That's it for our discussion on mirrors part 1. We'll continue our discussion on mirrors, image formation using mirrors. We'll continue our discussion in the next video. So, again, that's it for now, and thank you for watching.